So I'd like to start with a quote by a notable conservationist who said that whenever we let a species go extinct that we could have prevented its extinction, it's akin to burning down a library full of books that no one else has, or that no one has read. And so keep that in mind, because the devil's hole pupfish, there were only 35 individuals in the wild in 2013. And this is a species that's unique to Nevada. And also important to realize is that for years, people who have been working on vertebrate organisms have been using oxygen consumption as a way to estimate overall energy requirements or metabolism in an organism. So keep that in mind. So here's our pupfish, and that's the entirety of its known range. That is devil's hole. And devil's hole is low in dissolved oxygen, it's very hot, and there's not a lot of food there, so it's kind of a bad neighborhood. So we are lucky enough to have these fish in the lab, and we bring them into the lab, and we rear them from eggs in two temperatures which they see in the wild: 33 degrees Celsius, which is about 92 Fahrenheit, and 28 degrees Celsius, about 82 Fahrenheit. And what we notice is when we rear them at a higher temperature, you'll see that they hatch quicker. So if you think you're hatching quicker, well, you have to get your body ready. You have to use energy to do that. And when we also, what we see when we measure them, as far as how big are they getting when they hatch quicker, they're getting the same size. In fact, that graph shows that maybe they're even getting a little bit bigger, but not significantly different. And so when you think they're hatching quicker and they're getting to the same size, that requires energy to do that. And so obviously we wanted to measure oxygen consumption to see, are they using more energy? So this is the oxygen consumption across the development of an egg in these pupfish. And what you'll notice is that at 33 degrees Celsius, where they're getting their body ready to hatch and logically using more energy, their oxygen consumption at no point significantly increases. And in fact, as they get nearer to hatching, they're using 40% less oxygen than their counterparts that are reared at the lower temperature. And so what we really have is a really cool story for UNLV and for the state of Nevada, because here's an endangered species that's only found here in Nevada that is potentially going to force scientists to rethink the way they look at metabolism going forward. That energy has to come from somewhere to grow and to hatch, and it's not coming from oxygen consumption. Thank you.